Good morning. I want to ask two questions in today's talk. The first question is, what is social complexity and how do we quantify it? And the second question is, what is collapse of complex societies? And again, how do we quantify it? In both cases, my approach will be to bring massive amounts of data to bear on these two questions. But I should say that the first question, we are much farther along with answering using good data. And with the second question, we are just starting to approach it. So the general method that I and my colleagues use, we call it SESHAT, the Global History Data Bank. And SESHAT is this, you can see SESHAT depicted on both sides of the first paragraph. She is our patron deity. She was the Egyptian goddess of scribing. In fact, her name in ancient Egyptian means she who scribes. But she was also a goddess of not just scribing, but information generally and databases. In fact, she's often depicted inscribing data such as the length of royal reigns or agricultural productivities on a long papyrus leaf. And so we are trying to do the same. But the most driving idea behind constructing this database is that in order to test, we are lucky because, as Joel showed a minute ago, we have lots of theories. All right. So we don't lack theories. What we lack is data to be able to test these theories, because after all, scientific using new theories is only one part in the first step in any science enterprise. Rejecting theories, testing theories against each other by using data is the key step. And so that's the gap that we are trying to fill in. And our motivating knowledge is that collectively thousands of historians and archaeologists and other scholars of the past know a hell of a lot about human history. Of course, our knowledge is not perfect. We have lots of gaps, there is lots of uncertainty, there is disagreements between different authorities, but there is a lot of knowledge. Unfortunately, this knowledge is not present in the forms of data that would be amenable to parameterizing our models and testing model predictions against each other. And so that's our goal. The goal of the project is to build a web of facts about past societies which are connected along a variety of dimensions, spatial, temporal, and conceptual dimensions when two different variables are conceptually related to each other. We are interested in both looking for general patterns and also surveying diversity of such patterns in the past. And the primary goal is unabashedly scientific. We are interested in using this database to reject theories. And in fact, the measure of our success will be how well we populate the cemetery of defunct theories with slate theories. And by the way, just as an aside, theories actually do mind when we try to kill them, and so we do run into quite a lot of flack as a result of that. But that's that's expected. So very briefly, introduction to SESHAT is that because we are interested in serving the diversity, and also diversity is very important when you start applying statistical models. Your sample set should capture as much diversity as possible to be informative, to be so that we can actually reject theories with greater statistical power. And so eventually, actually, I hope I live long enough that we will be able to capture all knowledge that exists about past societies. But you have to be a bit more modest to start with. And so we have designed a sampling scheme that allows us to sample a number of diverse societies. And we do that by using a stratified sample. First of all, we stratified by the world region. And I don't know how did you get this thing to actually point. Yeah, okay, well, I'll just arm wave. We have 10 world regions like South America, North America, Africa, Europe, pieces of Asia and Oceania and so forth. All right, and so then in each of those regions, we select 3 regions which vary in what we are trying to understand, which is the evolution of social complexities. So we look at the antiquity of centralized societies. So we look within each, for example, within North America, we looked we went to Mesoamerica for the oldest centralized societies. We used Iroquois area for a more recent centralized society. In fact, the society was not centralized by the time Europeans arrived there. And Cahokia is an intermediate case. So the basic idea is to increase the variance in the data by including both the geographic component and also the component of social complexity. But this is just a sampling scheme. We don't really gather data for these localities. What we do with our unit of analysis is what we call a polity. A polity is an politically independent organization that can vary in scale from independent villages of farmers to chiefdoms, complex chiefdoms, city-states, empires, nation-states, and so on and so forth. So what we do, we go to each point of the 30 points on the map, and we drill back and try to capture the period between the agricultural revolution and industrial revolution. So this is all, we typically stop a couple hundred years before present, because our data collection and also the coding schemes are optimized for pre-industrial societies, actually for agrarian societies. So all societies, we don't sample foraging societies. All right, and so for example, in Egypt, we go back to the Badarian period, which is the first Neolithic period, and then we go all the way to the Ottoman Empire, and then just this is divided into segments, usually following the fairly standard chronologies established by historians who specialize in study of those regions. So it is actually not Egypt, but it is classic Old Kingdom or Ottoman Empire, which is the unit for which we collect data. All right, so currently we actually have started expanding the scheme. So it's now not 30 NGAs, these are the sampling points, but 34. We have 450 of these polities, but some of them are quasi-polities, such as archaeologically known societies. And we have a code book full with 1,500 variables, but of course, only about 1/3 of that is reasonably well coded, and for the rest of the code book, the data, we are still gathering data. And right now there is, roughly speaking, 300,000 Seshat records. And I want to emphasize that each record is not just it's a data point, but it also has explanatory paragraph, references, some discussion of why variable was coded this or that way, and so on and so forth. So there is actually, roughly speaking, 10 million units of data in Seshat that capture all that information. All right, so what I'll focus on, roughly speaking, just over 50 variables that we have come up with to quantify social complexity. And so we don't try to code social complexity by asking people, rate social complexity of this society on a scale of 0 to 10, because that would be garbage in, garbage out. What we have done, we we have run a series of workshops. In the beginning, we actually tried to divide social complexity into different dimensions, and actually Joe Tainter, people who have read him will recognize many of these dimensions. And so here, for example, we focus on things like social scale. What is the polity population? What's the population of the capital? What's the territory in square kilometers? So these are quantitative variables. What is the vertical complexity? How many different levels of hierarchies in various relevant sources of power in this society? And then a bunch of binary variables asking things about writing text. For example, is there religious literature or not? Is there history or not? Infrastructure, some economic measure, and the governance. So this doesn't sample everything that one could ask about social complexity, but we feel that it actually gets at quite a big chunk of it. Furthermore, as we found that empirically by analyzing this data set, so 450 societies, 50 variables for each, but of course you have some missing data, so it's about 18,000 data points. We found, of course, as you would expect, that there are strong cross-correlations between different measures of complexity. So here we tend to take many of the binary variables and combine them for a more quantitative measures. So for example, infrastructure is the sum of all present versus absent values. So when you do some standard statistical analysis, it turns out, for example, principal component analysis, it turns out that the PC1, the first principal component, actually explains over 3/4 of variation in the data. All right. Furthermore, if you look at how the PC1 correlates with all the different separate measures, which are called loadings, right, there is actually quite even distribution. So basically, what this suggests that there is such a thing as social complexity, all right, and we can capture it quantitatively, and it is a contribution from all the different things that we have looked at. So now we are in a position. I'll show you just 4 trajectories out of 30. So we are now in position to look at how social complexity evolves in different regions of the world. So here you see Middle Yellow River Valley, that's northern China, that's the red curve. Upper Egypt is, of course, Egypt, blue curve. And so you can see that, first of all, yes, you sort of you tend to start early on, you tend to start at low complexity, and you end up with high complexity. But there is much more interesting stuff going on than this. So first of all, in the timing of the transition varies quite a lot. How the pattern of transition, is it gradual or abrupt? That also varies quite a lot. And finally, complexity does not inexorably grow. There is lots of ups and downs in these graphs. And this leads me to my second half. So what happens when complexity declines? All right? And notice that this PC1 is really related to log transform things. So for example, population enters it as a log transform. So what doesn't look like a huge amount of change in this graph is actually could be an order of magnitude decline in scale of polities with which we deal. But these data are resolved only at 1 century interval, and that is too coarse. The time scale of resolution is too coarse to study the questions of collapses of social complexity. And that's why we need to go and sample our societies at a much finer temporal scale, at least decadal, all right? And also, we want to bring more quantitative measures in order to capture what actually happens during these collapses. or declines, as you wish, and also because our theories, the theories that we have for explaining the collapses, invoke some other measures which may not necessarily be relevant to social complexity. So here's just, as I said, we are just in the beginning of this second phase. But here's a teaser. We can look at such variables as the prevalence of collective violence. So political violence, which includes all kinds of events starting from urban riots all the way to a full-blown revolution or civil war, fragmentation, population collapses, and things like that. And if you do that, I'm just showing you just two graphs. One in the left upper corner is France going from 800 to 1700. All right, it's data based on Peter-Sorokin compilation. And what you see here is that there are recurrent peaks of political violence. And in fact, there is some interesting jagged sawtooth structure to these peaks. But let's abstract away from that. And what we see is that this recurrent pattern actually has a periodicity. So if you apply standard statistical methods like spectrum analysis, you find significant periodicities of about between 200 and 300 years in period. And so you have these century-long periods, very, very similar. It's quite low, which is periods of internal peace, or political order, and often accompanied by external warfare and expansion. And then there are periods of internal violence, the ages of discord, as I sometimes call them. And we see a similar pattern in Rome. And historians, of course, have noticed this pattern before. That's why these periods of internal violence, they tend to have names, such as like late medieval crisis, the 17th century crisis, and the transitions between different stable states in the Roman Empire. All right, so the theory for this, one of the theories that we plan to test comes from the work of Jack Goldstone, who is here, and my own, together with many of our Russian colleagues. So here are two relevant books. I don't have time, obviously, to go and explain structural demographic theory, but I just want to mention that it has been developed to the point of view of developing mathematical models and even and empirically connecting model parameters to data, and also we started testing model predictions. And what we see is that there is that this pattern of instability, which often and in extreme cases of instability, you have collapses, at least political collapse, is associated with cycles of well-being. So there are several case studies that we have studied for which we have actually quantitative data in which we can look at the patterns of well-being. And the well-being of broad segments of population is closely correlated with a negative sign with inequality. All right? And so here's, for example, this last line shows the two cycles of this well-being inequality in the United States. And so the periods of extreme political violence, often leading to some quite extreme events, are associated with those periods. Okay, I guess I'm starting run out of time. With this high inequality, low well-being. Now, Walter Scheidel, who's unfortunately not here, has an answer to this. Of course, he focuses primarily on inequality, whereas to us, inequality is just one of the components. So his argument famously is death is the great leveler. We actually have a bit more, I came out somewhat pessimistic in my previous comment, but actually I'm not a natural pessimist. And so here is sort of what we can say on the basis of the case studies we have studied so far. we can say that the entry into a crisis, we can call it revolutionary situation, is actually relatively stereotypical and generalized. But what happens at the crisis can be hugely contingent. So here is quick data slide showing 30 cases of revolutionary situations, all right, and what happened afterwards. So we rank the severity of component by looking at a variety of things, whether it's population decline, whether it's a huge population decline, what happened to the elites, dispossession, extermination, so on and so forth. And what we see is that the distribution looks like this. There is maybe 10% of the cases are fairly mild. The societies manage to go through these periods reasonably unscathed, all right? And then, of course, the great majority of historical examples, we have quite substantial amount of misery. So here's a cartoon that sort of summarizes the state of our thinking. There are two major components here. The top black curve is the well-being, and this is the social pressure for crisis. I don't have time to explain what goes into it, but I want to emphasize that this is a mechanism-based mathematical theory which has been empirically tested. So we have a very set of specific models. But what it looks like is that once you go through the crisis, there are all possible trajectories are opened up. All right, and of course, in historical cases, we are here rather than there. But in principle, here's my a bit of my optimism comes, is that it should be, even though crisis itself is inevitable, for example, in the United States, we are in crisis. But if we can take collective action, we can shade the trajectory from coming out of the crisis to more favorable outcomes, because historical societies did manage that. It's possible to do. So just to finish up, 10 years ago, I was asked by Nature to publish my prediction for 2020, and most people were talking about how wonderful technology will be, what we will learn in science, but I published a somewhat more pessimistic prediction based on this work. I want to emphasize that it is based on an explicit mathematical, empirically tested theory. And I must say, unfortunately, that we were somewhere here 10 years ago, and now we are much closer to this cusp point, and the social pressures continue to blow up. I think anybody who watches the American politics over the last 3 or 4 years doesn't need to be persuaded about that. Thank you very much.